Alright, breaks over. The set of all points in a plane whose distances from two fixed points in the plane have a constant sum. Whose distances from two, I'm going to underline that, two fixed points in the plane have a constant sum. The set of all points in a plane whose distances from two fixed points in the plane have a constant sum. Okay, we're just going to go down through and write all this vocabulary out, and then we'll draw pictures to talk about what this means. Okay, foci. The foci, some call it foci, I call foci, I don't know, is the plural for focus. Focus is singular, plural is foci, like celli, cellos, you don't say cellos, it's celli. Altos is not correct in singing, it's alti is the plural form of an alto in singing. Okay, foci. It's a plural focus, and these are the fixed points of the ellipse. Okay, right please. And I'm also going to add in that these are on the major axis, which we'll be defining in a minute. They're on the major axis. Plural for focus, they're the fixed points of the ellipse and located on the major axis. If you look below, we're going to define major axis in a few minutes. Okay, the focal axis is the line through the foci. Okay, the line through the foci. The center, which we know what a center is, right? Center of a circle, kind of the same deal as center of the ellipse, is the point of the focal axis midway between the foci. The point of the focal axis midway between the foci. Okay, we're going to draw pictures and label everything. Right now it probably feels like we're speaking a different language. We're going to draw pictures. You'll be okay. Vertices. The points where the ellipse intersects the axis. Vertices are the points where the ellipse intersects its axes, or its axis. The points where the ellipse intersects its axis. Okay, we just looked at standard form of a circle. Standard form of an ellipse looks similar, but there are some differences. The standard form of a circle, an ellipse. Does anything look different so far between a circle and ellipse? Nope. Okay, the difference is the x binomial there is divided by a squared. The y's binomial is divided by b squared. And instead of equaling r squared, the radius squared is equals 1. Because there's not a constant radius on an ellipse. If you think of an oval, it's different than a circle. So if you see fractions, and there's an x squared and a y squared, it's not a circle, it's an ellipse. Okay, chord. Chord is the line segment with endpoints on the ellipse. The line segment with endpoints on the ellipse. The ellipse, by the way, has 2 L's. Make sure you're spelling it right. L-L-I. Okay. The major axis, I've mentioned this once already. The major axis is the chord line on the focal axis. The major axis is the chord lying on the focal axis. Chord line on the focal axis. The minor axis is the chord through the center perpendicular to the focal axis. The chord through the center perpendicular to the focal axis. We're almost good. We're almost done. Okay, the semi-major axis is A. Now will you underline major, please? The semi-major axis is A, and I'm going to put in parentheses, it's the wide side. Guys, in the corner, wherever it's coming from, please stop. The semi-minor axis, I'm going to underline minor so I can see the difference between major and minor. The minor side is B, it's the narrow side. And the Pythagorean relation. Now on circles, I told you I'd tell you about this, but I forgot on the circles notes. Really quick, on a circle, centered at the origin, from the center of the circle, you can create a right triangle out to 2 points on the circle. If this is point A, then this side is length A. If this is point B, then this side is length B. How can we find the diagonal of a right triangle? Pythagorean theorem. A squared plus B squared equals C squared. But C, that diagonal, yeah, I'm not going to say that. Anyway, so that's why our circles have something squared plus something squared equals something squared. Okay, because we use the Pythagorean theorem. There's also a relationship here with the Pythagorean theorem, but it looks a little different. The relationship is A, meaning the semi-major axis a squared equals b squared, which is the semi-minor axis, plus c squared. C squared is the foci. Well, C is the foci. We should probably add that up to the definition of foci. Go up to the top and put C. Oops. What is foci? That's the major axis, and we get points C. So you know what A, B, and C is. Okay. The foci. Foci. Go up to the top and just label it C. I think we're going to stop right there. I'll tell you what your homework is on circles only. We have all the definitions of ellipses. So our next time, if there's time after this test, we'll start drawing pictures so we know what all these things mean. Our next lesson will continue with ellipses. You do have a test next time, so make sure you prepare. Your circles assignment is page 233. Yep, page 233. This is in volume 1, 2 through 22 all. And study for your test. The notes, all of our notes are due on the day of the test. Please bring all of your notes next time. The circles is not on the test. Okay, circles is due on Wednesday. Your priority is to study for the test and bring your notes on the test day, which is on Monday. Yeah? Yes. I've already done that for regulars. I just need to add in yours. Let me show you. I'll go to my website really quick. Yeah, toss the rulers in, would you? If there's time after the test, we can answer questions. On my website, if my computer works. Here's a list of the notes you need, but you also need to add in the honors notes, and I will update that on the website. Those are the notes you need for the test, as well as the honors 35 and 47 notes. Okay? Please return your calculators.
Another extra copy of that packet.
The review packet or the inequalities packet? I do. Just a minute. Thank you. Okay, Connor, here you go. Alright, I still have some calculators missing. If you have one of my calculators, please put the lid on and put it in order. Sierra or Marin, someone's phone's on the ground. If you're losing. Missing your phone.